let's briefly review our lesson from last class. We went over distributive property. We talked about the burgers and the fries and the nuggets and the drinks, remember? Okay, so if you remember, when we got done talking about, oh, my order was, let's say I ordered 2 burgers, an order of fries, and 2 drinks. Okay, remember at the end we would go through and we'd list everything that we ordered, just like that? Now, how come I didn't say, oh, well, guys, I ordered 5 burger fry drinks? Why didn't I say that, Kyla?
Because they're all like individual things and have different amounts.
Perfect. They're all individual things, and they all have their own amounts for each. What if I had said, hey, I want 2 burgers, fries, and 2 drinks, and then Seth is like, Miss C, give me a burger, and I'm like, whatever, Seth. So I get him a burger. So if I were reporting what I had ordered, would I say I got 2 burgers, fries, 2 drinks, and a burger? Or would I change it and say I got 3 burgers? Yeah, you would say you got 3 burgers, right? You don't list. So say you're having an eating contest with a friend at Taco Bell. Okay, you don't go, I had a taco, a burrito, a taco, a burrito, a taco, a burrito, a taco, a burrito. You would say, hey, I ate 5 tacos and 6 burritos. What'd you eat? Okay, you wouldn't go through the list and go taco, 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 burrito, burrito, burrito. Okay, you make these things, you do these things without realizing what it is that you're doing. Okay, you're combining like terms without even knowing that you're doing it mathematically. So today, there's no more burger, fry, drink examples. It's just numbers, but hopefully anytime you're confused, we can take it back to the burger, fry, drink example. Okay? So when you are adding or subtracting, okay, when you have a numerical sentence, all right, each part is called a term. The numerical factor of a term that contains a variable. Whew. How many of you read sentences like that in math and you're like, what?
What does that mean?
Yeah, yeah. Sometimes it gets a little wordy, okay? So instead of saying the numerical factor of a term, would it make more sense to you if I put the number with a letter?
Mm-hmm.
So a number with a letter like that. Does that make more sense to you than me saying the numerical factor of a term? Yeah, a little bit. Okay. So the number with a letter is called the coefficient. Coefficient. A term without a variable, aka a number without a letter, all right, that is called a constant. A constant. Okay, and like terms are terms that contain the same variables. Whenever you're thinking about that, think burgers and fries. So think burgers and fries. So like terms are whenever you have a list and you're talking about, oh, 3 burgers, 2 fries, okay? Think burgers and fries. You don't say burger, 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 fry, fry, fry. Quit coughing. Let's go get some water. Or you're smiling while you're doing it, dude. It's clear you're faking it, okay? Okay. I mean, like when you're like, okay. Okay, we'll go get some water. Like, I don't care if I'm being recorded, okay? So, remember, the number in front of the variable is called your coefficient, okay? Like terms are terms that look the same. So think burgers and fries, okay? So So in this expression, 3x plus 7 plus x. Okay, there are 3 total terms in this expression. We have 3x, we have 7, and we have x. 3x and 7 are like terms. If you are a highlighter person, I would highly suggest that you get a highlighter for today because I like to highlight my like terms. You don't have to, but I find it to be easier when I highlight them. Okay? So 3x and x are like terms. All right? And then 7 is our constant. So, quick question. If I have 3x in one hand and I have x in the other hand, together, how many total x's do I have? 4 x's. Sorry, I didn't know you were saying. I'm sorry. You were smiling, so I thought you were saying that. I mean, you like, what's it called?
You're not smiling. No,
Right. So, I mean, that's what I
you're not smiling because like you're understand why you go to bed.
I'm sorry. So, I mean, like, you know, Tiger sitting down there, like, over there. Yeah, Tiger, Jubei.
Tiger.
Yes, okay. Okay. So, in the expression next door to it, 4n plus 2n plus 9. All right, let's take a look and examine the pieces. We have a total of 3 terms. So, these are our terms. All right. 4n and 2n, these are like terms. And when I say like terms, I don't mean how you guys enjoy speaking sometimes. You know how you're like, oh, well, like, it's like math and stuff. It's like a term. Like a term, Missy. I don't know what it is like. It's like something. Okay, like terms means burgers and fries, all right? So this would be 4 burgers, 2 burgers, all right? Individual, separate pieces. So like terms. And then the last one on the end, that 9 is a constant. So a constant is a number with no variable part. So we can simplify our expressions by combining like terms. So for example, in the expression x plus x, do we see anything that is similar? Well, yeah, x and x. If I have x in one hand and x in the other hand, together I have how many x's? 2 x's. Remember, we talked about this when we were doing the distributive property. X is equivalent to 1x. It's just you don't write down 1x because it's repetitive. It's unnecessary information. You don't say, I had one, you would be like, I had a taco and a burrito. You could say, I had 1 taco, 1 burrito. It's not wrong, it's just unnecessary, okay? So it's singular. That x is just 1. Okay, so you have 2 x's. All right, and then this one over here. This is 4 groups. I mean, oh. This is 4 groups of 6x. So 4 groups of 6x. So 6x 4 times is how many x's? 24x. Good. All right. Yeah. No, my x is lowercase. It's just I write weird, so it's the same size. Okay, so part A. Part A says 3 times x, and then whatever you get for that product times 11. So let's break it down into each one step. So 3 times x is going to give me 3 groups of x is how many x's? 3x. 3x, good. So now I have 3x times 11. So 3 times 11 gives me 33x. All right. Thank you, sir. Okay, part B. X plus x plus x gives me a total of 3x. And part C. Yes, ma'am.
I have a question for number 2. If you put x through the could be wrong.
Yes, you need to. It's not x3, it is 3 x's.
Yeah.
So make sure you list your coefficient first. Yes, sir.
There's a part two.
No, and I'm going to talk about why. All right, so for part C, gonna highlight my like terms. I see 7x and x. So 7x and x together give me a total of 8x, and then I still have that plus 8. Now, 8x and 8, burgers and fries. Can you combine them?
Wait, hold on.
No. Those are different. 8 x's is different than 8. So you cannot combine 8 x's with 8. So this is as low as it can go. So your answer is 8x plus 8. Yes, Jaden.
Where did that 8 come from?
Where did the 8x come from? So again, this is what I was talking about before we started the lesson. Y'all kind of, it's been so easy, have zoned out, and we are not listening so much. So let's pay attention. So if I have 7x and x, this is why I highlight the terms that are similar. 7x and then x together give me how many x's? 8x. So again, if I had 7 individual x's, if I had 7 individual x's, and then I have one more x, how many total x's do I have now? 8x. That is how I got the 8x. That is why it's important, and some of you could really benefit from highlighting or circling your like terms. So, is there anything else I can do with that 8 right there? No. And I cannot combine 8x and 8 because they are not like terms. So 8x plus 8 is as low as it'll go. Yes.
So a number and a variable can't combine with extra?
Yes, because 8x is different than 8. 8x is like burgers. 8 is like fries. You can't put them together because they're totally different. Okay? Okay, they're different. All right. Now we're going to try and write an expression, and then we're going to simplify it. So this says 3 friends. So 3 friends will pay X for admission plus 1 to view a mummy exhibit. A 4th friend will pay admission, but they're not going to view the mummy exhibit. Write and simplify an expression that represents the total. So let's figure out right now, if it was just me going into the museum, my expression would be the cost of admission, which is what? X, plus the cost of the mummy, which is 1. But it's not just me. How many people are going into the museum? 3. So I'm going to take this expression, I'm going to multiply it by 3. But, Tyga, I'm not done, am I?
Yeah.
No, I'm not done. And if you were paying attention, you would know that instead of playing with Kyla's shirt or whatever you're doing. Okay? Yes. He is. It's okay. So, like I said, maybe we should make a better choice of seat. So, the 4th friend, he's not paying for the mummy exhibit, so we need to add in the cost of his admission. How do I add in the cost of admission? Plus what?
1.
Well, 1 is for the mummy, so plus X. Good. So now, the other day when we were talking about tripling something, 3 of combo meal 1, we took all of the contents of combo meal 1 and we multiplied it by 3. Same concept. We're going to triple the cost of admission and mummy. So 3 times X is 3X. And 3 times 1 is 3. But we still have our one friend who wants to go to the museum but doesn't want to see the mummies.
4x.
So we have now 3x plus 3 plus x. Now, does anybody see any like terms that we could combine? So, Ami.
The 3x and the x.
The 3x and the x. Good. So I have 3x and I have x. So together, 3x and 1x give me 4x. So my answer is 4x plus 3. Now I cannot combine this any further because remember, x is the admission cost. 3 is the mummy exhibit. You cannot combine them together. They are separate items. Are there any questions so far? Okay, so you can also combine like terms when you have more than one variable. So just think about it as burgers, fries, and then now a drink, okay? You can combine as many things as you want as long as you only put the like items together. So if I have x plus y, how many x's are represented in that sentence? 2. So I have 2x plus y. And that's as low as I can go. X and y cannot be combined, so that is my answer. All right, this next expression, what do we do when there's a number on the outside of parentheses? Yes, sir. Multiply. So 4 times 2x is 8x, plus 4 times y is 4y. Okay. Now we have 14y plus x plus 22y. Well, 14y and 22y are like terms. Can I combine them?
Yes.
Yes. So 14y and 22y give me a total of 36y plus that 1x. Okay, now we have 3x plus 9y plus 2x. 3x and 2x together give me how many x's? 5x plus 9y. So we've done pretty good so far. The next problem is a little bit challenging because it's the first time we're seeing a subtraction sign inside of our expression. So just be patient with the process. It'll make sense though, okay? So again, first thing we're going to do, when we have a number on the outside of the parentheses, Seth, what do we do with that? Yes, you multiply it by everything inside the parentheses. So 7 times 3x is going to give me 21x. 21x plus 7 times y is 7y. And then I'm just going to write in the remainder of the expression minus 8x plus 7y. Okay, so now that I've cleared my parentheses, it's time to combine like terms. All right, are there any like terms you see up there? Jaden, what do you see?
21x and 8x.
Good, so I see 21x, and then I see, and this is important, and make sure you're listening very closely, minus 8x. So you have 21x, and then you have, actually, that's negative 8x. But for the sake of right now, I want you guys to think about it like this. This is 21x minus 8. So if you have 21 x's and you take away 8 of them, how many x's are you left with? 13 x's. Okay? Am I done or do I have another variable? I have another variable. So now I have 7y plus 7y, which together gives me 14y. So plus 14y. Are there any questions so far? No? Okay, so turn the page. Let me go up.
So the next part is really the opposite of distributive property. This is another piece on the pre-test for the last one we did that you guys didn't do well on. So let's talk about it because we've given you all the pieces to be able to do this, but we haven't really told you how to put it together. So the other way we can find equivalent expressions is by what we call factoring an expression. It's just a reverse process of distributive property. So in this case, what I'm going to do is I'm going to look at basically the coefficients and say, what is the biggest number they have in common? Who remembers what we call that? What's the mathematical term for it? No?
Wait, what was it? Wait, no. Oh, greatest common multiple.
Greatest common factor. How do we find the greatest common factor? So, I mean, remember?
We add.
No? Okay. Cake, yes, I love the cake.
Oh, yeah.
So what I'm going to do is I'm going to take my coefficients and I'm going to throw them into the cake. 27, 18. I'm not going to worry about the variables,
3 and 2.
but I'm just going to worry about the numbers. So what goes into both 27 and 18? 9. If you did not see 9, go through your 4 key numbers. That's where the 2, 3, 5, 7 come in. You can see it was 3, then you did 3 again. But since I see it's 9 right away, what that's telling me is I have this common factor that I can pull out of both of those. So if I'm going to divide both of these by 9, 27x divided by 9, 27 by 9 is 3x. 18 divided by 9 is 2y. Now, as a side note, if they both had the same variable, I could also pull that variable out as well. But in this case, they don't, so it's just the numbers. So the next one, we're again going to look. I've got 36 and 60 as my two numbers. So 36 and 60, what goes into both? 6, good. So 6 and 10, will anything go into both of those? 2 gives me a 3 and a 5, will anything go into both of those? Nope. So again, remember, for greatest common factor, I multiply those numbers on the left side. So 6 times 2 gives me 12. So to figure out what the rest of the number is, now I divide both these by 12. 36 divided by 12 gives me a 3. 3x. 60 divided by 12 gives me 5. So if I were to multiply that back out, I'd get where I started. Make sense? 12x plus, which one? 12 times 3x plus 5. So it came out as 12 times 3x plus 5. Hopefully that's a little more clear. Okay? We're going to give you guys 5 minutes. See if you can factor those next 3. Yes, you may work with a partner. We have more to do. Guys, listen. Listen. Okay, I saw a lot of you trying to do it without the cake. Those are the ones that struggled the most. Guys, if you will do the cake, it is super, super easy. Literally, all I do. Whoa, what happened to my... Oh, I was using this, that's why. If I write down the numbers, 12 and 8, what goes into both? 2. I see a 6 and a 4. I always check what goes into both. 2. I see a 3 and a 2. Can't do that, so I multiply up the side. 2 times 2 is 4. If you saw that in one step, great, you did it in one step. But if not, you will get there, guys. That's the whole idea.
Awful lot of talking. I guess you want to do double the homework.
No. Wait. Did you forget the Y for the 2?
Yes. Sorry, I was listening to Miss Caruana. Okay, our next set of numbers, 35, 28. There's a couple of you new, so when we taught this, I always stress going through your 4 key numbers. Who remembers my 4 key numbers?
7, 5,
Okay.
2 and 3.
What?
7, 5, 2 and 3.
That's 5 numbers. Bobby?
Is it 3, 5, 7, and some other number I forgot?
2. Your 4 key numbers, 2, 3, 5, and 7. Literally, all you do, you walk through. Guys, please stop. You walk through, and I say, can I divide them both? Can I divide 35 and 28 by 2? No. 3? No. 5? No. 7? Yes. If I had said no one more time, that means they're prime numbers. I couldn't go any further. They don't have anything else in common. So that gives me a 5 and a 4. Can't go any further than that, so my common factor is 7. So then I'm going to divide both those by 7. Gives me 5x plus 4y. Now you may have noticed this also gives me my numbers for the inside. So double bonus on doing the cake method. All your numbers come right out for you. So now I got 16 and 40. What will go into both? 8. Okay, 8 gives me 2 and 5. Can I go any further? Nope. So 8, and they gave me the numbers 2x and 5y. Guys, is this making sense? Okay, so here's the key. Everybody see this big word here? Here is your homework. Not true. There's a lot of people that enjoy their homework. Yeah, there really are.
Have you met somebody who have problems?